My name's Anthony. I'm going to be answering your question today. So this is a bounds question, and we're doing an area question, right? So find the area of the region in the xy plane, bounded above by the graph of the function f of x equals 3, and bounded below by the x-axis, on the left by the line x equals 7, and on the right by the line x equals 20. So if we show this graphically, and I've kind of drag the graph over to the relevant coordinates, right? From x7 to x20, right? And then from x equals 0, or the x-axis, right? Or sorry, y equals 0, or the x-axis, right? Or to y equals 3, right? And this makes a rectangle. This rectangle, we can then find the area just by using visual observation, or if you want to use the calculus way of doing it, we can make an integral, right? And this integral can go from our lower bound, which was 7, okay, not 3, 7, to our upper bound, which is 20, for the function, which we're going to be like doing the area underneath, which is going to be just the regular function, right? Which is f of 3, f of x equals 3. So this is 3 dx. And then when we take this integral, remember it's the reverse power rule. So there's no coefficient. There's no variable here, or so it's an x to the 0. So we can make it an x to the 1. And then we just have to make sure we add a constant, but there's no constant in this case because we're just doing the area underneath this thing, right? Or we don't have an offset of some sort, right? So this is going to be taken from 20 to 7, and it's going to just be 3x. So then we evaluate this. That's 3 times 20 minus 3 times 7, and that's going to be 60 minus 21, which is going to be, well, if that was 20, that would be 40. So it's going to be 39. It's going to be your answer. And you can see this right here. This is 13, and this is 3. So 13 times 3 is 39. Look at that. We could have done that so much faster if we just didn't use calculus and just use observation. But later on, you're going to have to realize that if our lower bound is the x-axis, right, and our upper bound is some function, right? So let's say it's this function right here, right? Then we're going to have to use now this integral over here to do what we need to do, and this is going to be our f of x. And we're going to still use those same bounds, right? Because we'd be evaluating on these left and right bounds, right, which are going to be these numbers here, right? Our lower number is going to be our left bound, and our higher number is going to be our right bound. And we're going to be going, and the direction we're going in is important too, right? Because if I reverse these things, then it's like I'm saying, oh, take this backwards, and then I'm going to have negative numbers and stuff like that. So we want to make sure we do this in the right direction too, right? Going from the lower number to the higher number when we're evaluating this as area, right? Positive area. So there you go. Hope this was some insightful information. Hope you understood the answer, and have a good day.